So, I'll come now to the speakers of today. First of all, our chairperson, Mr. Professor Patrick Hitiarchy of the University of Calgary. Please.
Can be an independent person when I talk about the solid waste management and the issues that are important and things that you can think about and work on over time. So when I say innovative solutions here, I'm identifying some of the techniques being used in Canada, but I'll focus on the ones that are relevant here. I tend to shudder when somebody mentions that we should have incinerators. I look outside in Delhi in the morning, the mist is there, the fog is there, have another incinerator going up, producing a lot of smoke out there. And also when people talk about, I don't want to bring in the technology direct from there, the advanced technology, they're talking about increasing the emissions, decreasing the air pollution control. You have to be careful when you want to talk about technologies that can create more problems over time. I think, you want to look at the health of the people. The solid waste creates environmental issues, health issues. The same thing, incineration has created those things. That's why the US EPA has extremely stringent regulations. That's one reason the incineration is not being practiced that much in US right now. So the issues are more or less something that you want to think and apply from the context of what you have there. So if you have problems, don't create more problems over time. So my issue again is a little bit different. The way I want to present this is, you want to know where the problem started and why we are at this point, especially in countries like India. In fact, we have gone through this thing in North America and Europe. Go back 60, 70 years. There was enough land, enough places to put your waste. So that's what it was. But then, we increased the quantities, and now we are running out of space, and now we have created more problems related to the production of waste. So, have we sorted our problems in North America, in Europe? No. We still have problems. We are working on it. We will be working for the next generation. You should be learning from our experience over the last 30, 40 years. That's what my message to you is. Okay, so if you look at Canada, we produce 1 ton of per capita per annum of waste, and we have 30 million people, 30 million tons of waste. If you extrapolate to India, you will assume that you are going to produce that amount one of these days because your living standards are going up. That's waste is related to that. And also, if you follow the US and the so-called developed country lifestyle, you end up like us. That's not going to happen. We are talking about billions of tons of waste per year. So that's something that you want to worry about and something that you want to think before you talk about anything else. Okay, what is going to happen if you follow those the same things? So I have some numbers here that shows the amount of non-hazardous municipal solid waste we produce and how much it has increased. I mean, we have control to some level now. I think our rates are not going up, although the population has increased. The problem, the way that we look at the municipal solid waste management has been, in the past, open dumping was accepted, everywhere in the world. But later we figured out that, okay, there are issues with that, it produces leachate, it produces gas, it produces smell and all those things. So engineers said, okay, this is not acceptable. So we modified that. So in North America especially, what has happened was, the way the engineers did that is they look at the open dumping and look at each problem and came up with solutions. That's how it was done. So it is very simple solution in a sense. So we see open dumps there and it's not nice to look at, you cover it. That's simple as that. I think here in an open dump that was converted to a sanitary landfill. When you say landfills, there are two types. That when people talk about landfills, that's dumps. Sanitary landfill is the engineered landfill. So make sure you use the terminology properly. But the sanitary landfills has evolved over time. I think the first generation of sanitary landfills, we used to call them dry tomb type landfills. Basically, the idea was to minimize leachate problem because that was the biggest issues with this open dumping in the past. So you basically put a line out down there and then put daily cover and keep it dry, and that's your solution here. And this has been the practice, and then we have advanced the type of liners we use. We do have these membrane liners, leachate collection systems, all nice stuff, but associated with a landfilling. And then comes the question, okay, this is a solution. We know it's not a complete solution. Now, we know that there are issues with the long-term viability of this because we run out of space, and then we keep changing. So the thinking is evolving all the time. Okay, so just to give you some idea what these landfills look like, maybe fairly, when you look at the engineering aspect, it can be highly complex and it can be costly. Think about a landfill as something like a Mercedes Benz. But if you're a poor person, or maybe you have a very limited income, I don't think you want to go in this direction without really understanding the total cost associated with that. When somebody talks about having a landfill for 10 tons per day, I said, no way, don't ever think about that. Economy of scale is very important. What we have done in Canada, when there are communities that are producing small quantities of waste, we said, okay, don't landfill it, put in a transfer station, send it to what we call a regional landfill that has the economy of scale, large quantities, and then you can design it properly. So, that's a solution that's always going to be there because, you don't want to have small, bad landfills everywhere. You can have a good one landfill as long as you bring more material into the site there. So, don't want to show too much about this. The cells are constructed. Just want to show the type of material that you use. You can use geomembranes. You can use geosynthetic materials. Can be fairly extensive. And then this is a relatively small site, but then again, the cost can be fairly high. And then you can have all these leachate collection systems, as well as if you want to collect the gas, you can collect the gas as well. But again, remember that if you are collecting gas from a landfill, you have to have enough gas to make it viable to recover and produce energy. So quantity matters. That is an important thing to understand whether you're considering a landfill, sanitary landfills somewhere. Okay. So then over time we have realized that the leachate is not the only problem with landfills. And we realized that there is gas that is being produced. In the past, we did not extract the gas, and then we started extracting the gas at certain locations, and we found that the landfills does not have the ideal conditions to produce a lot of gas. If you don't have a lot of gas, you don't produce a lot of energy. If you don't produce a lot of energy, it's not economical. So we are going in a second generation landfills. We call the anaerobic bioreactor type of landfills. So the idea here is to provide the optimum conditions for the waste to degrade within the landfill, and it's in a sense it's a cost-effective way because we know how to design landfills and we use the same structure, but you get more gas out of that, and thereby you can make it a little bit more economical in producing energy there. So, in a sense, that can be advanced to another level where you can convert the same landfill into an aerobic reactor. Anaerobic means you produce your methane and you can extract the methane and produce energy. And if you pump in air into the same system, you can convert that to an in-ground composting system. This is more like a third generation landfills. So the thinking is evolving over time, and the idea here is once you have the aerobic system that's going in there, you stabilize it quickly, you can excavate the material, and you can recover the space. Space is a major issue in most developed countries. It's an important issue in countries like India as well as go to Sri Lanka. There's very little space available. How do you recycle the space within the same, using the same technology? Mine it. Mining is something that is being proposed as one of the solutions over the longer term. So you design for gas generation, highest level, and then mining and recovering the land. So this is what has happened with the so-called landfill option that we have been practicing. So you can start either from the beginning, start with the sanitary landfill, the so-called dry tomb first generation landfills, or you can start at number 2, the second generation, or can go to the third and start there right away, because we do have experience coming from North America and Europe. So what happens here is when you change the way that things are done, I have given you some idea what the gas generation rate is going to be. You increase the gas generation rate quite a lot, and then you stabilize the material in a fairly rapid time frame. You get 2 benefits. One is basically you get more gas and you stabilize the material and you can recover the space very, very quickly. So essentially, if you operate the landfill as a sanitary landfill as opposed to an anaerobic landfill, you slows down your reaction rates by almost an order of magnitude. It's like 10 times higher gas production with an anaerobic reactor. So the some information about what we are doing. In fact, we do a lot of recycling in Alberta, in North America. Does it make sense? The lot of times doesn't make sense. We do it because we like to do recycling, we contribute, because it is not economically viable. If you are taking the waste to a landfill, it will cost you $20 per ton. If you recycle, it will be $200 per ton. But North Americans and the Europeans, they have extra money, they can spend the money. But here, the way it should be done is a little bit different. In fact, you have rag pickers. I know the recycling here makes much more sense than in North America, because you can recover money and recover energy, and people can make it very, very viable there. So something that obviously works very well here. And some information about the so-called standard waste management hierarchy here. You do reduce, reuse, recycle, resource recovery from composting, and you can do incineration, gasification. These are all possible techniques. But when you want to apply these things, you want to pick and choose. Where what you do is depend on what your waste is and what your socio-political the system is going to be. So this is, in fact, the solid waste is not only a technical problem. It is primarily a social problem. We create that. So, it's like, you come and mess up your living room. You better clean it up yourself rather than asking somebody else to come and clean it up. So make sure that you understand that as a social problem as well. So the recycling, there are a number of different ways we do that in Canada, but I don't think they apply very well here. But on the other hand, I guess you have your own system. Definitely the rag pickers work. Those are people who have done that, but it's a matter of doing it properly. That's what we need to do. So that has to be done very well. Composting is very common over there. And but again, you have to understand the compost produce a material that has to have some value. Sometimes you can produce compost, a large amount. If you can't use it efficiently, you are wasting your time with that. In fact, it has happened in some places there. In fact, this is one of the largest composting plants in North America. This is a plant in Edmonton, city of Edmonton. From Calgary, this is city of Edmonton is about 300 kilometers north. And they take in about 200,000 tons of residential waste and about 25,000 of biosolids each year, and compost that in a fancy plant there. Will it work here? Obviously, it is expensive technology. This cost about $150 million to build. To operate, it cost about $25 million annually. So that's a fairly expensive system. But these are not directly answerable. One of the funny things about composting is essentially the large-scale composting originated in India. It was essentially taken over by the Europeans and the North Americans, and they are exporting back to you. So I guess the technology was developed here, large scale. The windrow composting, the windrow name came from somewhere here. So the issue is you have the technical expertise, you have the knowledge base that you want to start with. Yeah, use it in a way that is adaptable and that is more or less the homegrown kind of way, rather than being doing it from a foreign way, I would say. So here, this is a fancy system. They have this Municipal as well as windrow composting that's going on. Huge facility, large facility, costs lots of money to build these things, and Obviously it works, but they do have their problems as well with the heavy metals and other stuff in there. So as far as small-scale composting is concerned, you can do windrow composting, and we have other systems as well that's out there. But these are fairly well known. You can do it very cheaply, but the only thing is composting smells. That is one of the most problematic issues with that. So the location of a composting plant is critical, and if you want to make sure that it is publicly acceptable. So that is one of the important things to understand here. Landfilling, as I said, the landfill technology kept advancing in North America over the last 20, 30 years, and we are going through different stages here. And there are a lot of things that people are doing. Landfills are not being considered entirely as cemeteries like RIP, because you take something out of that. So the issue again here is that you can design the landfills to be more productive and eventually called sustainable, because we recover the land as well. So that is the technology that we use. Landfill gas extraction is very common. I think, I know the people who want to develop CDM projects, they do that quite often in collaboration with developing countries, whether in Asia or South America. That's very easy. One of the good things about this is very cheap, relatively cheap compared to everything else that's out there. So that's something that you have to think about. Obviously there are problems with landfills. There are, this nice picture of, what can happen to a plane that goes through a landfill site if possible, suck in a couple of birds, major disaster there. So that's something that I want to finish saying that, okay, there are a lot of different technologies out there. I think I mentioned before that, this not only the waste is not only a social problem, it has technical issues that you need to resolve. But on the other hand, you need to have people with different backgrounds working in this particular area, and also look from a number of different sides, not only from a technical side, not only from a social side as well. So that's my presentation. Thank you.
Thank you very much, Professor Hitiarchy, for this interesting speech. We have very nicely seen that all technologies can play a role in a sustainable waste management.